What are the three types of LM memorization proposed in the taxonomy based on colloquial descriptions of human memorization?
The three types of LM memorization proposed in the taxonomy based on colloquial descriptions of human memorization are recitation, reconstruction, and recollection. Recitation involves highly duplicated sequences in the training corpus, where the model generates verbatim copies of common texts like web page boilerplate, liturgy, or software licenses. Reconstruction occurs when the model learns templates and reconstructs samples based on broadly applicable patterns, such as repeating or incrementing sequences. Recollection refers to cases where the model memorizes rare sequences that are not highly duplicated or easily reconstructed, suggesting a more nuanced form of memorization beyond repeated exposure or template-based reconstruction.
How does the proposed taxonomy and heuristics help in categorizing memorized data?
The proposed taxonomy and heuristics help in categorizing memorized data by defining three types of language model, LM, memorization, based on colloquial descriptions of human memorization behavior. The taxonomy categorizes memorized data into recitation, reconstruction, and recollection. Recitation involves highly duplicated sequences. Reconstruction involves memorizing templates and reconstructing samples based on patterns, and recollection involves memorizing rare sequences seen infrequently during training. This taxonomy allows for a nuanced understanding of how LM memorization occurs and helps in identifying the factors that determine or signal memorization. By using this taxonomy, the paper conducts experiments to highlight the multifaceted nature of memorization, comparing memorized and unmemorized distributions to assess the influence of various corpus-wide statistics, datum-level metrics, and representational differences on the likelihood of a sequence being memorized. The taxonomy also guides the creation of predictive models that outperform generic approaches, demonstrating that the taxonomy can improve predictions of memorization based on different categories. Additionally, the taxonomy helps in understanding the dependencies between features of interest, with statistical tests confirming significant differences in dependencies across the taxonomic categories. Overall, the proposed taxonomy and heuristics provide a structured framework for analyzing and categorizing memorized data, leading to a deeper understanding of LM memorization processes.
What factors are considered in the paper to determine if a given sequence is memorized?
The factors considered in the paper to determine if a given sequence is memorized include duplicates in the training corpus, semantic matches, textual matches, token frequency, templating, compressibility, and perplexity. Duplicates refer to the number of duplicates in the training data for a given sequence. Semantic matches assess the similarity of samples in training using document embeddings. Textual matches identify sequences with low Levenshtein edit distance in their prompts. Token frequency statistics are computed for individual tokens in the sequence. Templating involves identifying predictable patterns like repeating or incrementing sequences. Compressibility measures how easily a sequence can be compressed. Perplexity, which is the average perplexity across tokens, is also considered as a factor, with low perplexity sequences being more likely to be memorized. These factors help in understanding and categorizing memorization behavior in language models.
How are the logistic regressions used in the paper to predict memorization for each category?
The logistic regressions in the paper are used to predict memorization for each category by training separate regression models for each taxonomic category. The paper divides the samples into recitation, reconstruction, and recollection categories based on the proposed taxonomy. Each category is then analyzed separately by training a logistic regression model with L2 regularization, a bias parameter, and balanced class weights. The training data is split into test and train sets, with continuous features normalized to zero mean and unit variance. The logistic regression models are trained on the training split of the entire memorized dataset and the entire representative pile sample. By using logistic regressions tailored to each category, the paper aims to predict memorization more accurately by considering the distinct factors influencing memorization within each category.
Can you explain the impact of model size on the different categories of memorization as discussed in the paper?
The impact of model size on the different categories of memorization as discussed in the paper is significant. The paper reveals that larger models tend to memorize more data, with recollection growing the most as model size increases. Specifically, recollection increases disproportionately compared to other categories, such as recitation and reconstruction, as model size grows. This suggests that larger models are more likely to memorize rarer sequences that cannot be easily reconstructed. On the other hand, the category of reconstruction barely increases with model size, indicating that even smaller models are effective at extrapolating, repeating, and incrementing templates. The findings show that the accumulation of memorized examples is not solely due to increased exposure to heavily duplicated samples, but also involves other factors that lead to the memorization of rare sequences. Additionally, the paper highlights that the proportion of recitation decreases relative to the overall amount of memorization as model size increases, further emphasizing the impact of model size on the different categories of memorization.
Based on the paper, how does the intuitive taxonomic model compare with the generic baseline model and the optimally partitioned model in predicting memorization?
Based on the paper, the intuitive taxonomic model outperforms both the generic baseline model and the optimally partitioned model in predicting memorization. The intuitive taxonomic model is composed of 3 binary logistic regression models that categorize samples into taxonomic groups before training a separate regression on each category. The paper states that the intuitive taxonomic model is better calibrated and more accurate overall, except for the recollection set where it has low precision. The study compares the performance of these models using statistical tests and finds significant differences in dependencies between features, supporting the intuitive taxonomy as an ontology. The paper concludes that the intuitive taxonomy can help predict memorization from dependent factors, and that the differences in dependencies between categories suggest the taxonomy expresses some natural kinds. Additionally, the paper mentions that the intuitive taxonomic model outperforms the optimally partitioned model, which was designed to have the same complexity but was based on different feature threshold combinations. Therefore, the intuitive taxonomic model is shown to be more effective in predicting memorization compared to both the generic baseline and the optimally partitioned models.